Hey you guys, welcome to video 6b. This has to do with circle angles and arcs, and it comes from section 10-2 of your textbook. We're going to start again like we did before with some new vocab words, and there are 5 new ones for today. So let's get going. The very first term is called a central angle. And the central angle's definition is an angle whose most important point, whose vertex, is the center of a circle. What you need to know about a central angle is that, and this is really important concept for this next video, is that the central angle always is going to equal the measure of the intercepted arc, or in other words, the arc that it gets cut off, parts of the circle that gets cut off by the arc, or by the angle. So now we have a diagram that can go with this. We have our center, and we've got our angle here. We'll call that JHK, let's say. Then this angle right here is the one that's known as the central angle. So just to kind of go along with the idea that we're saying about central angle and intercepted arc, the intercepted arc would be this JK here, and so you would just need to remind yourself that the measure of angle JHK is always going to be equal to the measure of arc, and we do a little curve over the top there, not a segment symbol, but over arc JK. So that's a really important central piece of information, no pun intended. Then we're going to go to talking about specific types of arcs, and the first one is a minor arc, ARC for arc, and that is an arc whose measure is less than, and I'll just highlight that, it's a less than symbol, is less than 180 degrees. That's your cutoff point for a minor arc. And as far as how it is named by using 2 points. So if we have our picture here, and we have our diameter of, let's say, CD with a center at E, and let's say we have another radius coming out to point F, then a minor arc in this picture, an example would be either arc FD, and you can see 2 letters is sufficient, or arc CF, and we'll just kind of highlight those. FD would be this much of the circumference of the circle, and CF would be this much, and both of those are less than 180 degrees. The next term we're going to talk about is major arc, and I think you can probably guess. It's the opposite of the definition we just talked about, so it's an arc whose measure this time is greater than 180 degrees. This type of arc is named with more than 2 points. It's with 3 points. And it's easy enough to remember that the minor is the smaller one, and so it has fewer points to name it. The major is the larger one, it has more points to name it. The diagram we're going to look at on this one is the same exact one we just drew, with CD going across the middle and coming out from point E to radius F. Only this time, if we use the same exact diagram and talk about a major arc, an example of a major arc would be tracing more than 180 degrees. So if I wanted that major arc right there that I just highlighted in red, that would be major arc C, D, F. So you want to make sure that you are naming it with 3 letters as it goes around the circle, whether it's clockwise or counterclockwise, it doesn't matter, but whichever piece you're naming, you need to make sure you have 3 letters there. Next term we're going to deal with is semicircle. And semicircle is an arc whose measure is exactly equal to our cutoff of 180 degrees, and it's also equal to half the circumference. Keep that in mind too. So this diagram's a little bit more complex, so I'm going to actually zoom in a little bit. And as we're looking at the diagram here, we're going to draw our CD, we're going to draw our EF, but I'm going to draw another radius coming out from E, and we'll call that point G. And there's 2 ways to name a semicircle depending on which side you want to. If we were talking about here our top semicircle, then we would want to make sure we're using 3 points that name and go through the semicircle here. So that would be major arc, C, F, D for that semicircle. If we wanted the bottom semicircle, we want to make sure we're going along the bottom, and 3 points that we would go through there would be C, G, D. Okay, so that's just a good idea to make sure that you know which semicircle you're talking about when you are talking about a semicircle. So let's go back over here. The last term we need for this video is arc length, and this is really important to make a distinction between arc length, which we're going to deal with in this section, to arc measure. They're 2 different things. This arc length is if we were talking about taking a part of the circumference of the circle and if we wanted to measure it, it's like straightening it out. So I just want to remind you here that that is not the same as its measure. We have a whole video that's just devoted to talking about arc length. And that does use a proportion, so I want you to know how to solve for that. Going over here, as we talk about how to solve for it, we're going to use a proportion to get there. And the proportion will be that whatever the arc actual measure is of the arc that we're looking at, and that'll be in degrees. So out of the total degrees in the circle, which is 360, that's going to be the same ratio as the arc length divided by the total circumference of the circle. So just a reminder that this is the piece that we're going to be looking for in those arc length problems. So you should be able, from the information given, to find the arc measure. You know it's out of 360, and then you already know how to find the circumference in the last section. So that's what we're looking at for our new vocab for today.